Today we'll determine the electric field for the special case where we have positive charges distributed uniformly along a wire. So using the superposition method is going to be very tedious because the electric field can be quite complex. So what we'll do instead is use Gauss's method, which states that the integral of the dot product between the electric field vector and the differential area vector over a closed surface is equal to the total enclosed charge in that surface over the permittivity of free space. And this expression on the left hand side is also known as the electric flux. Now, to avoid evaluating this integral, we need to construct this closed surface to utilize symmetry such that the electric field vectors are perpendicular to the surface. So in other words, if we look at this surface and take a circular section out of it, well, what this looks like is something like this. And the electric field vectors are always perpendicular to this surface. So really have a think about that. And consequently, if we take the length of this closed surface that we chose as Ls, so we can turn this integral into a simpler expression. So we have the electric field multiplied by the surface on which it's acting. So if we take a radius of this cylindrical surface as r, then the surface area is 2 pi r, being the circumference of this circle, and then multiplied by the length of the surface, Ls. And that's equal to the charge enclosed in that surface. So if we define a charge density, which is in coulombs per unit length, then multiplying the charge density by the length of that surface gives us the total charge enclosed in that surface. And we divide this by the permittivity of free space, according to Gauss's law. So we see that the length of the surface cancels, and then dividing through by 2 pi r gives us the electric field is equal to the charge density over 2 pi r epsilon naught. So we made this symmetry argument and constructed this surface based on the knowledge that we had on the electric field using the superposition principle. So if we took two charges next to each other, we can visualize that these vectors will cancel each other out, and the net electric field is going to be acting in the vertical direction and also coming in and out of the screen. Okay, so the electric field is always going to be perpendicular to the cylindrical surface, and that's why we constructed it in this manner. And I'll see you in the next video.